Welcome to the Refrigeration Mentor podcast. And this morning, once again, I got my good friend, Andrew Freeburg, Morning Coffees with Trevor and Andrew. We're going to be diving into some technical topics. We're going to be talking about the community because this is a community meetup. We love sharing, helping level up the technicians in the industry, in the community. And this is what we do. We're helping the industry grow by helping the technicians out there. And this is it. We got people inside this community who care, who want to level up, who want to grow. And that's what it's all about. Andrew, how you doing, brother?
Great. Fantastic. Morning coffee, refrigeration. What's better than that?
Not too much. Steven, my man, welcome. How you doing, brother?
I'm doing all right, Trevor. How you doing?
Oh, doing so great, my man. Doing so great. So, Andrew, we're going to dive in. I want to talk a little bit about some of the stuff that we've talked about. And we seen each other a few weeks ago at a training event down in California, which was awesome. I love getting to meet, hang out with Andrew. We made some videos for the CO2 Academy, some additions to the Supermarket Academy, which is fantastic. And then we just got to hang out and learn from each other, grow from each other. We're going to go through some of that. And we're going to dive into some stuff that's going on into the community, which is really good. I love seeing it as it continues to grow. Technicians helping each other, and that's what I love. So Andrew's an ambassador of a community and really helping the technicians out there, as well as Aiden is an ambassador who's answering questions. And this is what it's about: is how do we help each other get better faster, and not as much stress on their back, because that's one of the biggest things for the first 5, 6, 7 years in supermarket technicians. I had a lot of unneeded stress because of really my performance and my training and development, realistically, you know what I mean? Because I just wasn't an A player at that time, and a lot of stress was on it because I didn't really know what I was doing. We had lots of conversations lately about that, Andrew, and we see people in the community starting asking these questions that I really like to see. A lot of people are like, they'll message me and be like, I don't know if I should ask it. It's like a dumb question, or if it's a question that I should know already. But really, there's not really dumb questions. You know what I mean? If you're still learning. Now, if you all know the stuff already and you're just trying to piss people off or something, okay, that's different. You know what I mean? But this is not what we're trying to do. Any question, if you never set superheat before, you need to ask, like, how do I set superheat? Where do I put the gauges? Where do I put my temperature probe? What are your thoughts on that, Andrew? On the year for early years?
We all started at knowing really nothing in this trade, and it's all learning and just being aware and picking up from the other techs. We're all start at ground zero. So and now I see it now, because I had that same thought. I don't want to be looked at like I don't know what I'm doing, or afraid to ask questions because it's a dumb question, or potentially could be. I wish I asked a lot more questions sooner, and I wish I had some sort of support system like what we're trying to do here at the Refrigeration Mentor, the community here. If I had that, oh man, that would be a total game changer. I would have gotten up on the ranks, so to speak, faster, because I'm definitely not one to be afraid to ask questions, because that's how people learn, is asking questions and making mistakes and learning from other people's mistakes. So it's just all the process. So super important.
Yeah, I think that's a big thing, and we see this in the community all the time. Technicians coming in, they're a little iffy about the Supermarket Academy, you know what I mean? And then they start going through the academy, and we're getting messages. Both me and Andrew is like, I'm solving problems that my lead technician wasn't able to solve. And this is what is awesome. We see guys doing it for a couple of years, 2 or 3 years, and now they're solving problems harder than the lead technician. And it's not to downplay the lead technician; they just haven't been trained. You know what I mean? This is the industry that we're in now, is where here's the keys, or go out there, figure out, give me a call if you run into any issues. But this is what takes a long time to learn: supermarket refrigeration, CO2 refrigeration. you need that training, you need that support. And for the business owners, I don't blame them, because they're like, especially the business owner under $5 million, Andrew, you know what I mean? They're just trying to keep the lights on and the doors open. You know what I mean? They're just trying to get customers, and just trying to keep the business rolling. And it's hard to fit that training time in there. But you have to, you got to figure out a way to do that. And that's what Refrigeration Mentor is all about, is helping in that end, or even just send them to the community to get started, just to ask the question. And we're going to talk about some of the tech in the community that are starting to ask more questions, which is really helpful for us, because we know we got hundreds and hundreds of people in the community, but we know there's a lot of people that have questions, but they're afraid to ask, and that's okay. But we'll get to a point where you're going to share more pictures, you're going to share more videos, you're going to ask more questions. That's really helpful. This weekend, Andrew actually was helping a technician, Jacob Decker, out in the field. So shout out to Jacob. He's new, he's up and coming in the industry, but now he's starting to ask more questions, giving him some support. We want to talk about that support call that you did with Jacob.
Yeah, no, again, great that Jacob's he's been posting stuff on the community too, which is perfect. And I can't stress it enough. Like, if you have a question, post it on there, because you're probably not the only one that has that question. So yeah, shout out to Jacob for just going out there and asking some of these questions. Yeah, the question that I got was what we were diagnosing was one of the cases. It was a glass door case.
The fans, or something was going on with the fans, or like,
yeah, it was the fan. I can't remember the brand. Zero Zone. Jeez, Zero Zone. And we were just going through it, and the fans weren't on. So we found out that the fan clicks on was bad, but we pulled the PDF and started looking at the wire diagrams and started going that route. And yeah, it's just, that's what this community is about, is really just supporting each other and moving, helping us move forward and gaining knowledge and stuff like that. So yeah, whatever we can do to support, I mean, that's what we're here for.
Yeah. Let's dive into a couple of weeks ago. So me and Andrew met up. We were at a training event in California, Concord, and we were at the, was it UA 342? I think it was 342.
342, yeah.
Yeah, at the NSARC event, and they have system LMP rack there, which was really good. So we got to play around on it for quite a few hours. We were making some videos, which I love making videos with Andrew, because he's very thoughtful on what he's saying and how he articulates what is going on in the system. And this is what, the CO2 Academy is all about, is just learning step by step as you grow your knowledge. And it's about repeatability. Like, I talk about over the last 4 or 5 years talking about CO2. I continue to talk about the same thing, because it's that one message that clicks. This, me and Andrew talked about it before. Like, you can hear it a bunch of times, but you hear it this one certain way, and then all of a sudden the light bulb goes off. What were your thoughts about hanging out, making some videos for the CO2 Academy, Andrew?
I mean, hanging out, talking about refrigeration, making videos. I mean, I live and breathe this stuff. I absolutely love it. So of course it was the highlight. I mean, no doubt about it. Yeah. So then just walking through the entire system, I think that's an important, if you go to a rack and haven't really done much at that store, yeah, just take 10, 20 minutes and just go fully through the rack from the discharge line, just like how we did, and went through the entire system. And then, yeah, and then it just really helps you go through any rack, really. If you keep doing that, the first time it's going to take slow, it's going to be slow, but the more and more you do it, the faster you become, the quicker you're going to understand what's really going inside those pipes.
Yeah, and we'll dive into some of the videos that we made up, but we were attending some of the classes together as well. So here's a shot when we were at the. Let me just pull this one up. This is when we were at the BOC training, and that's there is Michael from Danfoss, and they were doing a teardown, which is great. I love compressor teardown, and I've done tons of them. I was with Manuel Frochulet, who's the head BOC guy. I've done tons of podcasts with him on all their different compressors. Now Danfoss has purchased them, so they're under the Danfoss brand Bach, and they're moving into North America, which is great to see. So if you want to check out some great Bach videos, head to the YouTube channel, because I have a great teardown. Manuel goes step by step going through the Bach, how the flow goes, issues that we can see, you can see in there from system related issues, because we know most compressors failed from a system related issue. You want to talk about what was going on here, Andrew, in this picture?
Yeah. Let me see here. Well, yeah. There it is. Can you guys see that, Trevor? Can you see my arrow? Or no?
No, but
Okay. Well, the little tube that's sticking, yeah, right there. The little tube sticking out, that's actually a pickup screen on this Bach compressor. So I was curious of like how it was attached. How do I get to it when I got to clean it, because it's potentially going to plug up someday. But what we're doing here is this is the check valve for the oil. So it can only build up so much pressure. And then right where he has that screwdriver, that's where the check valve the pressure will overcome that check valve or differential valve, and then it will blow the oil out at that point. So I didn't know if it was going to be at the front of the compressor where the oil pump is, which in this case it is, versus the back of the compressor. So I was just really seeing the internals of how this thing operates is super important. The cool note that I've got with Bach is that every single reciprocating compressor, I think that's all they have, but I don't know. But all reciprocating compressors have a positive placement oil pump. So I thought that was pretty cool to know.
Yeah. And so they're built right in. Like if you're used to working on like Copeland HFC compressors, for an example, you would have the pump that would come off. You know what I mean? You'd pull the pump off the housing, where these ones are built right in, which is really cool to understand. And once again, you got to get into these compressors and take a look at them. You know what I mean? We pull the stator out, because you can pull the stator out of these compressors and replace them if you need to. So that's a differentiator versus some other manufacturers, where if the stator fails, is done. Like in an example on the Bach ones, you can actually replace, going back to the way it used to be, where you can replace a lot more parts in the field to really help that customer out, because we know a lot of compressors fail due to system related issues. And we also know that a lot of compressors are replaced and not the root cause found. And sometimes it's not even, the compressor's not even failed. You know what I mean? And so we see that, and I've done it before. And this is why it's so important to continue to learn about how each compressor manufacturer builds them, works them, and sets them up. So I thought that was a couple of takeaways on from that session, Andrew.
Taking the stator out was so cool. I'd never done that on a compressor, because like you said, once they go bad, you just swap it out a new one. So I thought that was pretty cool to experience and do. I mean, we literally sat there and we tore this whole thing apart to see how it was all taken out. And basically you take the end bell off, and there's a couple set screws I remember, and then it just slides right out, and then toss that one, throw a new one in, and bolt it all back together with new gaskets. It was a really cool experience to get to be there. But I would say that was probably the biggest thing that taken away. And then the how the pickup screen works on that. Like you have to take that whole end bell off just to.
And then you can take this off right here, I'm pretty sure. So you take off this pickup screen, and then you can blow this out, right? When you take that,
right, but you still have to take off the whole, or I guess the front bell of it off. So that I thought that was unique versus a Copeland. So I don't know. They were saying that they're going to probably change that design when I talked to David.
I think it's Michael.
This guy's name? Michael. Dang it, Michael. That's right, Michael. Yeah, I talked to Michael, and he said that they are going to change it like how the Copeland is. So that's just getting there and. But no, it's cool. It's cool to be a part of it, taking stuff apart, actually seeing how it works internally. That's kind of how I really figure out stuff is I have to tear it all apart. Compressors, when they fail, I take them all apart no matter what. I know it takes a little extra time to do it, but that gives you the exact reason why that compressor fails. So I'm a huge, let's take it apart because I need to know.
Yeah, totally. I totally agree with that. The big thing is understanding all the components inside the compressors, right? Like you're saying, taking apart. Like most manufacturers, you're not able to pull out the stator because you got to heat up the casting, and so when you heat up the casting, then you can drop out the stators where they do it a little bit differently on the box. But here's another photo for those of you who are listening. So this is actually the end bell, like the suction side, with the suction screen. So it's nice. It's cool to see the way different manufacturers do it inside their compressors, because there's lots of times that if you don't know that there's not a screen in there, then you don't know. And you can run into issues if these start to plug up. Once again, they should never plug up because your system should be clean. There should be no dirt in the system, but we know when there's tens of thousands of joints, welds, hundreds of different people working on this. Well, not usually hundreds, but dozens of people working on the systems. It can start to add dirt to the system, contamination. What are your thoughts on testing and looking at suction filter screens? Because I don't think a lot of people check that.
No, it's honestly one of the checks. If you got some compressor failures or problems, oil problems, that's definitely something that you got to check. And like you said, some people don't even know it's in there. Shoot, I mean, when I first started, I didn't know that there was anything like that. Suction pressure is crankcase pressure. You know what I mean? Yeah. But I know now that there is a big difference, and that screen right there, that where your arrow's sitting at, that can plug up. I mean, I've seen it happen before. Maybe not on a Bach per se, but definitely other compressors. So it's something to be aware of and take note and put it in your back pocket when you're trying to figure out what's going on with that system. So yeah, huge, very, very important. But look how many bolts are on that compressor housing compared to another one. That is so cool to see. If you guys haven't worked on CO2, I thought that was a trip when I first saw that. Was how many bolts is required to hold that sucker on? So
almost 24 on that one. Yeah,
it's nuts. It's so cool.
Yeah. So you definitely need to get the torque specs if you're pulling this off. You got to have the gaskets and stuff, and you really need to know what to do. I'm enjoying seeing people in the community start to work on actually replace parts on compressors more and more. I know I've done a ton of trainings with contractors or technicians saying well, Trevor, I deemed this the valve plate, but the end users just change the whole compressor. We don't want to risk it, and the compressor is only 2 years old. There's tests to do. And if you do those tests properly, you can figure out what component is broken in the compressor or not working properly. And a lot of times you can just replace that. But if you make a mistake, because they're worried about making the mistake where, okay, let's change the valve plate, and then all of a sudden the compressor is still underperforming or it failed after, a week or two. So then, you know what I mean? They're looking at the value versus the valve plate versus a whole compressor. But when you really understand how to troubleshoot it, 8-9 times out of 10, it's better just to replace the part than the whole compressor. Now, if the compressor is 20 years old, you're going to want to replace it. 15 years old, if it's been beat up for the last 15 years and it lasts that long, because compressors are tough. Most compressors are pretty tough. Probably should think about getting it replaced. But there's a lot of opportunity in a newer compressor. You could just change component part on it. What are your thoughts on that, Andrew?
I always leave it to the customer what they decide that they want to do. I come up with the option, so if there was a compressor that's down, I think it's the valve plate, isolate it. I'll have at least gaskets in hand, pull the heads off and look. And if I see that it needs a new valve plate, then I put new gaskets on and tell them what's going on. But then the question becomes, what happened, right? And that's where we got to go in, dive deeper, because if it did it once, most likely it's going to happen again. So that's why we dig into it deeper and figure out exactly what's going on there. Yeah. So, but needless to say, options. I just give the customer options, and I don't give them 100% either, because I'm not going to sit there and say your 5-year-old compressor, there's not internal damage when you have a valve plate that's busted. Just say, well, everything looks good as far as the teardown goes. And in my opinion, we could get away with just the valve plate. It's going to cost X amount versus a new compressor, which will have a 1 to 5 year, depending on what they choose, warranty on that compressor. So like I said, I make the customer be the one to decide what they want to do.
Yeah. And so a lot of people don't know. So I worked for Copeland for a long time before I started Refrigeration Mentor. And I don't know if they do it with their CO2 compressors, but I'm sure they do. They can have you can get a 2 or 3 year warranty on those compressors if you do a proper startup procedures. Most manufacturers, and Copeland, I don't know about their CO2 once again, but most of the time, like from the first failure, they used to not even inspect them. They would send out a new one. The second one they would inspect, where there's other manufacturers where they inspect everyone. Copeland, I remember that we always taught about they want you to pull it apart to look inside to see if you can figure it out. And other manufacturers don't even want you to open it. Like I know a lot of times Doreen, when I talk to them, they're like, don't open it. We want to inspect it to make sure it's nothing on our end, because if you do open it, you can maybe change what it actually looks like inside. You know what I mean? And then I know Bitzer, they just inspect everyone. That's what my understanding. They inspect everyone, and there's a lot of denied claims. So there's different ranges on the way to the manufacturer. So you should find this information out. You know what I mean? From the different wholesalers as well, because this helps your customer, right? If you can get a 2 or 3 year warranty versus just a 1 year warranty, and it is something that was caused by, say, for the manufacturer on their end, that's going to, help that customer out, where if it's a 3 year warranty versus if you only have the 1 year warranty, and it just say it is something to do with the manufacturing of that compressor, then your customer's out. You know what I mean? So something to think about a different manufacturer. And you need to go and find out. I don't know if it has changed or not from any of the manufacturers, but go talk to the wholesalers and challenge those wholesalers. And if those wholesalers or distributors don't know, say, who's the rep for this compressor manufacturer? Like, who's the rep? I need to talk to them so I get a better understanding. You know what I mean? So we should not be relying on other people's information. We're the experts out there. So let's dive in a little bit deeper. Does this take longer? Yes, it does take longer, but it's so important to understand those different routes.
Yeah, stay curious. That's awesome.
Yeah, no, I love it. So this is a post that Andrew put in the community too on from a CO2 system. There's a lot of things that I'd love to talk about here, but right off the bat, what do you guys see? What do you see? If you know CO2 and you work on CO2, what is one of the things that you notice right away? Because when Andrew sent this photo, he's like, look at this, Trevor. Check this out. You know what I mean? What the most important sensor, Andrew, in a CO2 transcritical booster system is what sensor?
Your drop leg sensor for sure.
Yeah, that gas cooler
the
outlet.
most important sensor out of that whole entire rack.
Yeah. And I was doing a training last week or 2 weeks ago, and the like we do field assignments where they'll go out and they'll take pictures and they'll get the PNIDs and electrical wiring diagrams. They'll build a whole little project on their different stores so they can start learning and they can teach their whole team. You know what I mean? This is the whole purpose of coming to Refrigeration Mentor training. So I can teach you so you can teach other people so we can make the industry better. And there was one where that drop leg sensor, they showed it. It was inside the mechanical room, 30 to 40 feet away, 10 meters from the gas cooler, just before the high pressure valve, upstream of the high pressure valve.
Wow.
And he was actually able to just lift the insulation. It wasn't even barely on there. So he could just lift the 6 inches or, 3 inches of insulation that they put on there.
Yeah. I mean, if you look at this one, you can see that there's no insulation. It's just a reflective piece of tape, Inside there was the thermal paste, but that's not enough. That's not enough. So today I will actually complete this job. So I will be posting another, I guess, before and after photo of this system here. But I'm going to be totally covering that up. I actually did. I just got to put the PVC jacket around it. If you guys know what that is, but you will. If you don't know, you will. I will be posting this today, so I'm super excited to get this one done. But yeah, that sensor that Trevor just circled in blue. Yeah, that's. I mean, it's just not enough. It's just not enough. So I actually went all the way out of the gas cooler there on both sides. Yeah, I covered that, and then I actually extended 12 inches past the sensor as well, as far as insulation goes. And then today I'll be going around with a PVC jacket, so it's going to be all nice and covered and weather protected. Yeah, so I'm pretty excited about it. But
I'm pumped up too, and I want to see. We're going to look at the graphs afterwards. You know what I mean, and kind of check out the difference. What I see in so many, like all the trainings, all the technicians sending pictures in, I see this is what I would see right here. I would see this insulated. That's it. You'll have that 3 or 6 inches over that. Okay, that's the only, and bared. Like all this is bare, unless it's industrial. I'll tell you, the industrial guys that doing CO2, they do it right. They insulate that whole drop leg right from the gas cooler all the way into the high pressure valve. Like I've seen it countless times in industrial. I don't know why in supermarket we don't do this. Like right here, this pipe right here that is exposed, all of it. What's happening in that pipe when it's 110 out or 40 degrees Celsius? Okay, if our sensor's right here. Okay, what happens if it's minus 40 out, minus 40 Fahrenheit or Celsius? What is going on with the pipe right there? If this is the most important sensor and this in the drop leg, wouldn't that be important? Is there any efficiency losses there? And I don't know the exact answer. I don't get the data to back it up, but I know for sure, or I believe. Sorry, I shouldn't say I know for sure. I believe if this is insulated way better, it's going to read better, and your high pressure valve is going to run better. What are your thoughts, Andrew?
No, I agree. It's if the manufacturer anything CO2, we all know that drop leg sensor is the most important. Why would we want anything to affect it? And that's just going to affect everything downstream, which is everything else. So yeah, we definitely want to make sure that that system is reading exactly what that drop leg temp sensor is reading. So no, 100%. You don't want the heat, you don't want the cold, you don't want the sun rays, you don't want the water. I mean, get everything eliminated off of it, and then now we know for sure, like that is what that pipe is reading, or that sensor is reading what that pipe temperature is.
Yeah. And I was with the experts of M&M Carnot a few weeks back. One of their engineers, designer, super smart dude. And because I was doing some Carnot training on some of their racks. And one of the things is I showed them a video of one of their systems. And there's like, oh, man. Because I didn't have all their documents. I've seen some of their documents, but one of their documents that they send out to all the sites, like that the technicians or the contractors should see, but I know a lot of times they don't see that. Construction is night, you just go and you start piping and nailing it all the way. But he showed me a document that is right in their package where it says, okay, they want the sensor right here. So so there's 2 drop legs. So if you're listening on the podcast, so there's 2 drop leg, there's 2 sides to this gas cooler. It's a BAC. So you get 2 circuits, both circuits tied together. They want to always, like our M&M kernel, always want to have it after the both circuits closest to the leaving circuit, the last circuit going out. And in their instruction, it says they want to see at least 48 inches of insulation. So if you have to put it this far, they want to see it from the gas cooler all the way past that sensor, kind of like you're doing, 12 inches past. So they'd like to see that about that 4 feet, that 1.5 meters of insulation. And it says minimum 1 inch insulation, strapped down properly. And they want to do it at about a 30 degrees from center. So if you do, for an example, if this is the pipe and here's center, they want to have it at like 30 degrees, whatever 30 degrees is there, strapped down good. And then you have that 1 inch insulation, and then you have that PVC layer or whatever that protective layer is to keep that insulation out of the elements. Right. Which I think most manufacturers, that's what they want. There are other manufacturers. I know my friend Paul Bennett from Hill Phoenix. He's been on the podcast many times. He likes to see the sensor as close as possible to the pre-cooled side. That's where. So on the whatever side is the pre-cool. So inside these adiabatic coolers, there's going to be a sensor in between the pads and the coil, and there will be a sensor in there understanding where that adiabatic condenser is at. So if it's on this side here, we'll just say if the sensor's on this side, he likes to see the sensor right there, and then this whole thing insulated like that. So depending on the manufacturers, they may say it one way or the other. And I've had people tell me, oh, that's wrong, or that person's wrong. It doesn't matter to me. I recommend starting off with the manufacturer recommendation. And then if you have to test, do your test. That's what we do as refrigeration technicians. We do tests. What's your thoughts on that, Andrew?
Yeah, I always have said go with the manufacturer recommendation. They have tested it, and they have tested it. And any, the extreme conditions and stuff too. So I highly recommend doing that. And then if it's still causing problems, which, sometimes it does, definitely go with your experience or your gut and test it out. Like you said, there's been times where I have to do that too. So, So no, I agree with you for sure.
Oh yeah, I love that. So thank you for sharing that with the community. I know that definitely has helped tons of people, and more people working on CO2. That's where, you know what I mean? You're going to start to see it. If you're in the supermarket game, you are going to start to see more and more CO2. And I see tons in industrial. I'm starting to do more industrial contractor training because they're starting to see it. They're starting to see CO2 take the place of where they used to have ammonia. Because if you have to have over 10,000 pounds of ammonia, in North America, it depends on where you're at in the world, you need a mechanical engineer on site full time. You know what I mean? So all these different things. So they're trying to get lower charges. And CO2 is like a really great option for maybe a combination ammonia CO2 system, or CO2 pump. So there's different options out there for CO2, which is really cool. And we're going to see more and more of that. Yeah. So
I'm excited to see the revolution or the change of what really refrigeration's headed. That's really the big reason why I moved down to California, was to get more hands-on CO2. So I'm loving the change. It's just, I'm super excited for it.
Yeah. No, I totally.
Oh, let's talk about, that, nope, to the right. This one. So I had a call, I think it was this week. Yeah. This week, not yesterday, but the day before. That frosted line is actually your liquid line. Okay. So it was so nuts. I thought that I got a restriction somewhere. I'm gonna, there's a big problem here, is what I really thought was happening. I pulled one of the cases that was having an issue, and that's the first thing I see. Never seen that before unless there's a big restriction, right? But yeah, that is your liquid line right there, which was crazy. Yeah.
It's frosted right up. You don't usually see. The only other time, honestly, I've seen this kind of happen before is in we had at the training center a CO2 cascade system, and the subcooling was crazy low and it wasn't insulated. So the liquid, you know what I mean? The liquid line was going through, or not the cold space. It was just a humid space. So as it was running, it would get super frosty. because then it wasn't all insulated. That was another problem. You know what I mean? So there was spots. So when it go and defrost, all of a sudden there's a puddle on the floor. So that was kind of the only other time like I would see a liquid line get really frosted because you're just so cold, right? You know,
Yeah.
you're below the dew point. But this is in the case, and this is the liquid line. That should be a warm, because this one, does this have a subcooler on it? Was there a subcooler on it? Not even a subcooler, just straight from the receiver.
From the flash tank. This is a CO2 unit. So no, but really there kind of is because of that high pressure valve, does that. But yeah, no, it was super crazy. But needless to say, I did throw a graph on there too. I didn't even check the flash tank because I just went straight to the E3, looked at it, and then I found the flash gas bypass valve saying that it was at 0%. So I was like, oh, it's stuck open. That's why my pressure is low on the flash tank. And the flash tank was running at 400, 420. So it's definitely really low because medium temp's running about 420 discharge. Anyways, started checking it out. I ended up shutting the ball valve off for the flash gas bypass valve, and pressure didn't rise. I was like, what in the world is going on? So then I decided to pull the cover off the float, and then I realized we were that low on charge, and that's what was causing that frost. So I had to add 300 pounds of CO2 to this sucker. Everything went away. Everything started pulling back down like nothing even happened. But yeah, that's if you ever come across this on a CO2 unit, definitely. I did not know this until not yesterday, but the day before. I did not know like that would happen. So I thought that was a pretty cool feature to see there.
Because usually, like I said, what do you think's happening here? And when I looked at it, I didn't know the system, even if it was CO2, but I knew that it was, usually you see that with a restriction. That's something
Right.
that you would start to see with a restriction. But this is not the case. Well, I guess it's a type of restriction. There's no refrigerant. So the restriction is no refrigerant. And you said that when you went and looked at the flash gas bypass valve, it said 0%. Is that right? And you just thought it was, but you thought it was open, but it was just reading incorrectly. That's why you closed it?
Yeah, if it said 0%, because my flash tank pressure was so low, but if it was at 0%, that valve is shut, right? So then it was like, well, it should be building pressure. Like, why isn't it? It must be stuck open. So I just slammed that ball valve shut to see if I could build pressure in that flash tank. Never did. So I'm like, So then that's when I went to the flash tank itself, pulled the little cover off with the little indicator in it. But yeah.
Yeah, and this is it takes experience. If you never worked on it before, you want to understand the ball valves you're closing. Andrew's an expert at CO2, and he's been working on it for years, and he's getting better and better. And he's taken a lot of training for it, and he consistently do it, and he trains it now. The big thing is that looking at those graphs, like he did, he went and looked at the graphs, like what's going on? Why is this 0%? Probably looked at the high pressure valve. He did send the graphs, and we'll take that up some other time, but this is something important. Understanding the laws of thermodynamics. You know what I mean? We reduce the pressure, we reduce the temperature, we increase the pressure, we increase the temperature of refrigerants. And this is what happens. It was getting colder and colder, and then we started to freeze on there. That humidity, so any moisture that's in the air started to stick to the pipe because it's just so cold. I'd love to see it. I don't know if you have a picture afterwards and what it looks like, but it'd be great.
I do.
Good.
I do. I did send it in there.
Yeah, I love it.
I did. Yeah. No frost now on that liquid line.
Yeah.
I think there's a frost right where the that is a pulse valve sitting right there in the corner.
Yeah.
I think there's frost from that point into the evaporator, but yeah, I did end up posting that. I guess I wish I would have explained what was happening here because it just because it's so crazy to me. Like I'm like, how does this even frost up like this? minus a restriction, and it was just low on charge. So it's obviously boiling as it goes through. The pressure is so low, like you said. But yeah, I thought it was super cool to see. I was a little blown away by it because I never seen a rack so low on charge on CO2 like that.
Yeah. And this is how we all learn, right? And you've been doing this for 18, 20 years, and it's consistently. What's great about this, we're always learning in commercial refrigeration, supermarket refrigeration. I see my good friend Eric Holland put in the comments. This was for the picture before. So if you guys remember seeing the gas cooler, and we're talking about the gas cooler, he always recommends placing the ambient sensor between the pad and the coil as well, but never touching either. I totally agree with that, because your gas cooler needs to understand what the ambient is on that side of the pad as well. So that's going to help control the fans and give the fans a better idea of what is going on with that gas cooler. So you do need to have a sensor there as well. Eric, I would love to ask you, do you have an ambient sensor and then on the outside as well? So you have the actual ambient and then one between the pad and the coil as well. So two different ambient sensors, or do you just use that one? You can throw it in the chat. Oh, there you go.
Yeah, here we go.
Come on, man. How you doing? How you been?
I'm good, thank you. And you look fantastic too. We only have the one sensor, so in between the pads.
Okay, great.
And the same with the droplet sensor. Yeah, the same recommendations as the other guys said. Both the manufacturer and Andrew place that sensor a good foot after whatever connections you have out of it. First horizontal pipe, about a foot from any connections. Good connection to the pipe with the thermal paste. You can choose to place it at 4 o'clock or 8 o'clock at your discretion, but just make sure that it is really firm on there. So use a pipe clamp. And not a plastic, cable binder, because that area will be hot and cold, and eventually plastic breaks. So
okay,
all your insulation, everything.
From the T, you would like to see it about from the T here. You'd like to see it to 6 to 12 inches, so 150 to 300 mils from this.
Yeah,
point,
but.
So
we
realistically,
recommend at least 200 mils.
200 mils. Okay, so like between 6 and 12 inches. Okay, I like that. So Andrew, that might be the spot there. He's like, oh, I got to go back and do it. But Andrew does that stuff. He goes in and does it right. And I think that's a good point, because there's probably a lot of turbulence right here or happening with that flow and the
exactly.
Flow.
Yeah. What you have to think about, what is it we want to measure in this system here? What is it we want to measure? Just want to measure whatever pipe, how hot the pipe is? Do we measure the gas temperature? Do we measure the liquid temperature? Or do we want to make sure that we do not measure the oil temperature? Because there will be a lot of oil in this system, and the oil temperature, we don't care about the oil temperature. We can't expand that anyway. So we want to measure the liquid and the gas temperature. And that's why we want to place it up at 4 o'clock or 30 degrees, as you say, from center. So we are sure we are out of that oil pocket.
Yeah, I love that.
Yeah. I love that. And it takes a bit of time for the gas and oil and everything to settle down when it's twisting through connections and everything and bends. So that's why we want to keep that about 10, 12 inches away from any connections.
And then so that's there. So I got a question for you, and maybe you have tested this over the years, Eric. Why don't we insulate from the gas cooler? Just say it's 10 meters away into the inside of the building, so it goes into a building. Why wouldn't we insulate that the whole way? And why do manufacturers not say that anywhere? Is there a reason for that?
I would recommend doing that. It is not end of the world if you don't, but you will have a drop in temperature depending on mass flow, temperature, ambient temperatures, and pipe length. So it can be quite significant. So if you measure the temperature on the rack and directly on your drop leg, that could maybe drop 5 Kelvin or something like that.
Yeah. Yeah, like almost 10, 11 degrees.
10, 11 degrees, yeah.
And that's and how does that, how would that change the system now if we get that bit massive drop from where your gas cooler outlet sensor is into like that 10 meters, 15 meters away, 30, 40 feet into a hot mechanical room? Because you could be dropping into a mechanical room, and I've seen it where it runs 20 feet before it hits the high pressure valve, 20, 30 feet. And then in that mechanical room, you're always running at 25 Celsius or 75 Fahrenheit.
Yeah. Normally, in normal temperature ranges, it doesn't really matter at all.
Okay.
But if you have really cold, let's say your unit is just next to a wall for the outside, you draw your line to the outside wall and up to the roof on the outside, and you're maybe let's say 20, 30 feet away. Then you can have a significant subcooling of that liquid coming home to the rack, and that can cause the pressure in the receiver to drop because you're just dumping in a lot of super cold liquid into your receiver, and if that is, the receiver will be, at I can't remember your pressure, but at 40-ish bar, that is, what is that, 680 psi or something, ish. Then the temperature in your receiver is about 4 degrees C, or I can't do that in
it's 530. Yeah, it's 530 psi, and you say 40 C.
Yeah.
That's 95, or that's 104. I think 40 C, 104 Fahrenheit.
Oh no, 4 C.
Oh,
4 degrees C. Yeah.
Oh yes.
So your temperature in receiver will be about 4 degrees C.
Yeah,
so
40 degrees.
4 degrees above freezing. But if your liquid coming home from the roof is like maybe like 0 something like 32 Fahrenheit.
Yep.
Then it will inevitably drop the pressure in your receiver.
Yeah.
And you might drop the pressure so much that you lose your feed pressure to your expansion valves. Yeah. And then baby dies, right?
This is gold information.
So if you're in a cold climate, then you want to insulate that droplet pipe all the way, at least to the inside of the building.
Yeah. And I love that. This is what I talk about in the training programs, and I'm talking to them about, like, this is all exposed, and they're like, well, subcooling is good because subcooling is good, right? But the problem is with CO2 system, too much subcooling could cause an issue. And even in an HFC rack, if you have a subcooler on there, if you're running your subcooler too low as well, like if it's too low, then that now those valves could be oversized that they've been set up for. You know what I mean? So this is why you really got to understand the dynamics of the system. So Eric, thank you so much for that. That definitely cleared so much up for a lot of people out there, and even me, giving me a better understanding. When you get too much subcooling, you drop the pressure in that receiver. When you drop the pressure in that receiver, it drops the pressure differential across those EEVs. So just think about this whole. It's like a whole ecosystem. It's a
whole chain of events here you need to keep track on. And the rule of thumb, not to take much more of your time, rule of thumb: just keep your droplet temperature a handful of degrees hotter than your receiver. So like 5-7 degrees hotter than your receiver. Then you'll always have good temperature coming in. You will always have a positive pressure from the gas cooler side to the receiver, so you can actually move the liquid in the right direction.
Yeah. And this is something that I've been seeing hugely, and we can talk with Andrew about this too, but a lot of the programs that I'm doing, training people coming into the community, talking about CO2, their biggest issues are in the wintertime when it's like minus 20 out. And not understanding, like, I'm running into an oil issue now. Why is it running into an oil issue? All summer it ran okay, but now in the winter I'm running into an oil issue. And now this is like your oil reservoir running off your flash tank pressure. Your flash tank pressure drops. It drops so low that you're not a high enough differential over the sump or the suction of the compressor. Now we can't move that oil from that. And then you get an oil issue. So I just love learning this stuff. Thank you, Eric, so much for sharing that.
Oh, you're welcome.
Andrew, my man, what do you think of that?
Gold information. Yeah. I mean, I picked up some stuff there too. So thank you, Eric, on that. I appreciate that. And I mean, the more we talk about it, the little bit of information, just as simple as the turbulence going through that T, it's just like, well, that makes total sense, as soon as it gets pointed out. But this is part of the reason why I love talking about refrigeration, because there's always stuff to learn. There's never a point in my whole career where I was like, oh, I know it all, because there's just so much stuff. So I love it. No, I appreciate Eric, you giving the insight for us. So that was perfect.
Yeah. And this is what the community is all about. Sharing, learning, growing. So if you're interested, go to refrigerationmentor.com/hub and join the community. These are experts from all around the world who are willing to share their knowledge with you. And I know for sure, 20 years ago, it wasn't the same. We didn't have access to information like this, but these are professionals who want to help you grow and get better. And this is what I love about it. Andrew, I think this was a good morning coffee. That's for sure.
Yeah, you can't beat that.
Yeah. Any final thoughts, Andrew?
Yeah, there was a question on the very top here with that little hand valve. They asked if that was yeah, there you go. That was the purge valve for if there is non-condensables in there. Definitely, it's always piped to the highest point, and you see how it kind of U-bends backwards, I guess. That is exactly what that sucker is to purge out non-contaminants in the system if you have it. Other than that, on the top left, you could actually see that was open at that little tab up there. So that portion is where the water would go in and then distributes out. If you guys ever looked at this is how it reminds me of, but if you guys ever went to, worked on an ice machine, a cuber, that's kind of like the same thing. It distributes the water falls onto those pads, and then as the air goes across it, it evaporates, it cools the air, and then it actually hits the condenser. So it's kind of like a swamp cooler. That's exactly what it's doing, is a swamp cooler. So it works really well on dry climates. If you have any questions on that or whatever, that's how that works. So
Was that open like that when you got there, or was that you lifted?
yes, it was open.
Yeah.
Yeah, so I was like, well, that's kind of strange. In this instant, this whole thing was, I was here because they had a whole rack down. I got here, someone had the condenser turned off up on the roof here. And then when I got up here, this is what I saw. I'm like, what in the world? That's open, that sensor, so it's just like, well, that's interesting. So then I button it all up, and then I'm making that sensor better. Like I said, I'll have a photo in the community there so that you can see the after. But yeah.
Yeah. And I did, this is a BAC. So a few weeks ago, it's on the podcast too. I got 2 sessions with BAC, Greg Martel and Al Riviera, I believe his name is. And we dive into everything BAC. So how the pads are. So at least these are incorrect. They said they've seen it before where this is at the bottom. You know what I mean? And it's just going in there. It's never going to travel through. The water needs to go in here. This distributes the water, and then it travels down through these pads. Talked about how to clean it, how to set up their gas coolers. So definitely go to the podcast or the YouTube channel and check it out if it's on Apple or Spotify. Andrew, this has been huge, man. This has been huge. Learned a ton. Eric, thank you so much for taking the time. Steven, thanks for showing up, and everybody else chiming in. I really appreciate that. And this is what we do. We're helping industry out. So if you're listening out there on the podcast and you're interested in getting into a community that cares for refrigeration professionals, head to refrigerationmentor.com/hub. And I'll always just try to level yourself up, learn a little bit every day. Read something every day, try something new, and ask questions. Get out the P&ID like we talked about, get out the wiring diagram, get out the IO list. And if you don't know what any of those things is, ask in the community. We'll help you out. And we're here to help you grow. Andrew, thank you so much, brother. Eric, Steven, looking forward to seeing you guys at the next community meetup.